Good evening, everyone. Let us consider this question 2. It was a continuation on that other video, but there was just a mistake that was there on the formula. Just made a mistake. Under this topic, we have a lot of formulas that we have. So, the question is saying a gas cylinder has capacity of 200 centimeter cubed. Calculate the number or the moles of carbon dioxide that can fully occupies it at room temperature. So whenever you see the volume, it's there. The formula that you need to know, there is a formula that we can say number of moles is equal to volume over molar volume. So our data. The first thing that we need to correct that they are saying, we have volume. This volume, it must be converted into decimeter cubed. How do we change it? We divide by 1000. So we can say 200 centimeter cubed divided by 1000. So our answer is going to be a 0.2 decimeter cubed. Then what is our molar volume? The number of moles we don't know. It's the one that we are looking for. The molar volume, we can say at RTP, when they say RTP, it's room temperature and pressure. Always the decimeter, the molar volume, is a 24 decimeter cubed. It's a 24 decimeter cubed under room temperature. So how do we find our value? We can say number of moles is what's the volume, 0.2 decimeter cubed divided by a 24 decimeter cubed. So if you use our calculator, we can say a 0.2 divided by 24. Our answer there is saying 8.3333 times 10 to the power negative 3. So it's saying 8.3. It's saying 8.333 times 10 to power negative 3. So this, how do we change it? How do we remove this in this form into a standard form? We can say, since there is a negative there, 3, we can say it was 0 point. Then we need to add how many points? 3 points, 3 zeros. For I to reach at 8, you can say 0, 0, 8. What number of moles? You can say moles. If you want, you can just leave it here. It's correct as well. It's correct as well. Yeah, so another question is saying this was 1. If you say 2, 1, A1, what of 2? The question was the moles of carbon dioxide that can fully occupy it. The 2 say the moles of carbon dioxide that can fully occupy is at STP. So our data, they are asking us for the number of moles. Number of moles we don't know of carbon dioxide. Then what's the molar mass? According to our formula, our volume, we need to find the volume. Remember our volume there, it was a 200. It's a 200. So how do we change this into decimeter cubed? Into a decimeter cubed, we divide by 1000, of which we did it already here. Our answer is 0.2. So we can say our volume is 0.2 decimeter cubed. Then what is our molar volume? So it's different. This was TP, RTP. Now this one it is ACTP. This means that is a standard temperature and pressure. So our value is 22.4 decimeter cubed. That's our value. It's different from RTP. It's different from RTP. This is STP. It's to 22.4 decimeter cubed. Then how do we find the number of moles? We can say number of moles of carbon dioxide, we say volume over molar volume. So what's our molar volume? We can say volume is 0.2 decimeter cubed divided by what's our molar volume? It's 22.4 decimeter cubed. Then what is our final answer? When we divide this, we can say 0.2 divided by 22.4. So our answer is 8.928571429 times 10 to power -03. So if you can say this is our answer. If you want, you can change it to a standard form. You can say it's 0.00, then we say 8 or 9, since when we round off there, can say it's 9. It's 9 moles. If you want, you can leave it here. If you want, you can just extend it to be this 0.009. So this was the solution to our question 2. Then we have another question under concentration. So they are saying concentration is the amount of substance dissolved in a unit